All right, folks, in this video, we are going to be doing more with augmented matrices, turning a system of equations into an augmented matrix, and then using row echelon form to solve. So I'm going to start by looking at my system. I've got 3 equations, which means I'm going to have 3 rows in my matrix. And even though this first equation doesn't have a z in it, since I have 3 variables plus the constant, I am going to need 4 columns. Now, before I put these in an augmented matrix, remember that for row echelon form, we want to get a 1 in that top left position. Could I get that if I divide this whole equation by 2? Yeah, but that's going to create a fraction with the y, which this matrix stuff is already tough enough, so maybe we shouldn't try doing that. Same with number 3, or the second equation. This actually doesn't have any x with it. So I'm going to go ahead and write 0x. So is there an easy way for me to make that 0 look like a 1? That's going to be a no. So this equation has a negative 1 with the x. So we are going to take this equation and write it above. So negative x minus 4y minus 5z equals negative 10. I'm going to go ahead and cross that off so I'm not tempted to rewrite it a second time. So just put a note that we're going to reorder the equations because negative 1 is easier to make 1. All right, so now that we have our new equation set up, we are ready to make our augmented matrix. And folks, make sure you leave some space above your matrix so you can show that row operation work. So I'm gonna hug my matrix pretty close to that left side there. And I'm going to start by writing my x column, so negative 1, then 2, then 0. And you can do it a row at a time if you want. I tend to go by columns though first. It makes spacing it a little bit easier. So then in my y column, I'll have negative 4 and 1 and ooh, so be careful that you don't accidentally write 2 here because my y for this one is actually 3. Then my z column, negative 5, and what is my z value in this equation? There isn't one, so 0, and then 2 for the z in that column. And again, if you want to draw that dashed line to show the variable stuff separated from the equals constants, that's totally fine. So negative 10, negative 4, and positive 8. All right, folks, so to make this look like row echelon form, we start column by column. We need a 1 in that top left position, and we need zeros below it. So don't worry about trying to get like this 2 down here to be a 1 at this point. You always want to take it column by column because otherwise the work that you've done over here is going to interfere when you rework those other columns. So this is the systematic best way to do it, just like we eliminate one variable twice and then eliminate with those other 2 equations. So again, it's very similar to Gaussian elimination. It's just organized in a different way. So the good news, folks, is we already have that 0 on the bottom that we want, but I do need to change both row 1 and row 2. So how can I make row 1 be a positive 1 instead of a negative 1? You could add row 2 to row 1 if you wanted, but it's actually going to be easier if you just divide by negative 1. So remember, you don't always have to like eliminate or add 2 rows together. Sometimes you'll be able to just manipulate the row itself. So which row am I replacing? Row 1. What am I replacing it with? Either negative 1 times row 1 or negative 1 under, or row 1 divided by negative 1. So a couple different ways you can write the work for that. So my new row 1 will be positive 1, positive 4, positive 5, and positive 10. All right, now I need to make that 2 look like a 0. So the easiest way for me to do that would be to multiply row 1 by 2, which would give me negative 2, and then add it to row 2. So I'm going to replace row 2 always start with the row you want to change. We're replacing row 2 because we want to make that 2 be a 0. And how are we going to do that? By multiplying 2 times row 1, which will give me -2, and then adding it to row 2. Alrighty, so if I multiply row 1 by 2, I'm going to go ahead and write that down below since I already have stuff written up here. So row 1 times 2 would be -2, -8, -10, and -20. And being careful, we are now going to add that to row 2. So -2 plus 2 is 0. -8 plus 1 is -7. -10 plus 0 is -10. And -20 minus 4 is -24. Alrighty, and we already have a 0 in row 3, so we are good to go there. So 0, 3, 2, 8. So we now have the first column of row echelon form looking good. We've got our 1 with our zeros below it. So now we are ready to make our next column of row echelon form look the way it should. We need that -7 to be a 1, and we need the 3 to be a 0. So row 1, after you have used it for those first manipulations, it's kind of going to be off limits, because if I multiplied this by, let's say, -3/4, and added it to row 3, that would put a -3/4 here, which I would add to 0, and that would ruin the zeros that I have in my first column. So as a general strategy, once you've used row 1 to do those first manipulations, it becomes off limits. So let's go ahead and look at that row 2. So how can I make row 2 have a 1 there? Let's go ahead and do the simple thing, which is to simply divide by that coefficient, or divide by -7. So which row are we going to replace? Row 2. What are we going to replace it with? We're going to take row 2 and divide it by -7. So it's going to get a little bit icky with fractions here, but that's going to give me a 0, and it's kind of tough to tell that that is a -7. There we go. So that gives me a +1, a +10/7, ew, and a +24/7. Nope, don't like that. But that is the proper way of doing the row echelon form. So row 1 is going to remain the same. And now let's talk about row 3. Now we need this to be a 0. Row 1, if we did anything to that, would interfere with that initial 0. So I have to somehow use these 2 rows to get that to be a 0. So what I would do, and again, think about if this was -7y and 3y, we can multiply these rows by the opposite one's coefficients and then add them together. So let's go ahead and write those steps first. Which row are we replacing? Row 3, because we want this row to have a 0 there. What are we going to replace it with? We're going to take row 2 times 3, so 3 times row 2, and then row 3 by 7. That will give me -21 and +21, which when we add those together, that's going to give me the 0 that I want. So I'm going to go ahead and show the work above here for row 2 and down here for the manipulation of row 3. So let's start with 3 times row 2. 3 times 0 is 0. 3 times -7 is -21. 3 times -10 is -30. And 3 times -24 is -72. Next, we're going to multiply 7 times row 3. So 7 times 0 is 0. 7 times 3, 21. 7 times 2 is 14. 7 times 8 is 56. And now we're going to add those 2 manipulations together. So 0 and 0 is 0. Yay! We've maintained the integrity of that first column. And then -21 and +21 is 0. -30 and 14 is -16. And then negative 72 plus 56 is also negative 16. Whew! So that one was a little bit more tricky, but again, if you can think about what you would do with the regular variables in place of the column positions, if the rows were equations, that kind of will help you with this process. So looking for row echelon form, column by column, we've got our 1 with our zeros below it, our next one with our 0 below it. Now our last step is getting this to be A1. So easy enough to do so. We're going to take row 3 and replace it with row 3 divided by a negative 16. And that will give me 1, 0, 0, 4, 1, 5, 10 sevenths, 10, 24 sevenths. And then divided by negative 16 gives me 0, 0, 1, 1. And that is the lovely row echelon form. So that's our goal in these problems, is to get our matrix to be REF, or row echelon form. So now that we have our REF set up, now we can set up our equations from this augmented matrix, and we can back substitute up the 1 variable, 2 variable, and 3 variable equations. So again, this is my X column, my Y column, my Z column, and my constant. So again, if it helps you, you can put that dash line there. So looking at this bottom row, we always start from the bottom. How many variables does this row or equation have? Doesn't have any X's, doesn't have any Y's. This bottom row just says 1Z equals 1. Or Z equals 1. Boom. There's the first part of our solution. We move on to our next row. This, as an equation, says 0x plus 1y, so 1y, plus 10 sevenths z equals 24 sevenths. So there's always an equal sign between the z and the c. Now, if you're getting a little bit uneasy going, oh, those yucky fractions. So if we put that 1 in for z, we get y plus 10 sevenths times 1 is 10 sevenths. And if we subtract 10 sevenths from 24 sevenths, we get 14 sevenths. So y equals 14 sevenths, or y equals 2. So that nasty little fraction stuff, it actually worked out nicely given our other fractions in the problem and gave us a nice y equals 2. So now I have 2 out of the 3 variables. So now our last row says 1x plus 4y plus 5z equals 10. So x plus 4y plus 5z equals 10. And now we're going to take that 2, plug it in for y, take that 1 and plug it in for z, which will give us x plus 4 times 2 plus 5 times 1. So that gives me 8. That gives me 13. So 10 minus 13 gives me x is negative 3. And that gives me my final coordinate answer, negative 3 for the x, 2 for the y, and 1 for the z. And folks, going back to what we've been saying throughout this chapter, after you get that coordinate, even though they're all integers, which is a pretty good check that you've done everything correctly, it's not a bad idea to take it and plug it back into all 3 original equations to verify that it works. So that is row echelon form. That is the solution to our system. So let's go ahead and move to the next problem on this page. And you can go ahead and pause the video, and I'd like you just to see if you can write the augmented matrix for this one. So I'll help you out a little bit. We've got 3 equations, so 3 rows, and we've got 3 variables and a constant, so 4 columns. So we're going to make a 3x4 matrix, and don't forget what we did on the last problem. It's a good idea to check that top left coefficient because it's easiest if it already is a 1 or is easy to make a 1. So I'm going to go ahead and leave the equations in those orders. So pause the video and go ahead and write that augmented matrix. There's our X column. Here's our Y column. There's our Z column. 1, 1, -1. And then our constants. 7, 14, 3. All right, so there is our augmented matrix. So now it's row echelon form time. We've got our 1 in the top left position. We need these terms to be zeros. So again, if it helps you, you can think, how would I get these x's to cancel or be 0? Well, we would multiply our first equation by -3 and then add those 2 equations together. So transferring that to our matrix work, which row are we going to replace? Row 2. What are we going to replace it with? We're going to multiply row 1 by -3, and then we're going to add that to row 2 to get my new row 2 and to get a 0 in that position or to get the x to cancel. So folks, I recommend you pause the video again and see if you can write your new row 2. So before writing the row 2, what I would do is show that manipulation of -3 times row 1. So -3 times 1, -3, -3 times -2, +6, -3 times 1 is -3, and -3 times 7 is -21. Next, I'm going to add that to row 2. So -3 plus 3, 0. 6 and -5 is 1. -3 and 1 is -2. And then -21 and 14 is -7. So that would be our new row 2. Row 1 is going to stay locked in now that we have that 1 in the top left position. And now we take a look at row 3. So we also need that 2 in row 3 to be a 0. So how would I get that x to eliminate? We'd multiply the first equation by -2 and then add them together. So how do we do this with matrices? We are going to take row 3. That's the one we're going to replace. And what we are going to do is multiply row 1 by -2. So -2 row 1. And then we will add it to row 3. So let's go ahead and show our manipulation work below row 3. So I'm going to take -2 times row 1. So -2 times 1, -2 times -2 is 4. -2 times -3 is +6, question mark. The reason why I just intentionally made that mistake is it's very easy as you're multiplying the matrix rows by something to accidentally go to some of your work above. So I would like you to have that work so I can see it, but just be careful that you don't accidentally shift up and look at the wrong numbers. Sometimes students will literally cover things up or go like this. So find a method that works for you so that you don't accidentally multiply it by a manipulated number. So -2 times plain old row 1, -2 times 1, -2. -2 times -2 is 4. -2 times 1, -2. And -2 times 7 is -14. All right, and adding those rows together. 2 and -2 is 0. -2 and 4 is 2. -1 and -2 is -3. And 3 and -14 is -11. So sweet, we've got our first column of row echelon form completed. So now we move to our next column. So we need a 1 in the slant down position, and we need the term below it to be a 0. All right, so we've got our 1. That's nice. We need to make this positive 2 be a 0. So can I just add row 1 and row 3 together? Nope, because negative 2 plus 2 is 0, but that 1 would ruin the integrity of that first column. So again, folks, after you've completed that first column, row 1 is going to be kind of useless. So let's go ahead and write our manipulation work for this one. Which row do we need to replace? Row 3. What are we going to replace it with? Well, we're going to multiply row 2 by negative 2, and then add that to row 3. So negative 2 times row 2, 0. Negative 2, positive 4, 14. And then adding those together, we get 0. And, oh no, there's 0. And 1 and 3. And then our other rows stay the same. So let's see how we're doing with row echelon form. Woo! We've actually got our entire slant of 1s that we need and the 0s below it. So this is in full row echelon form, which means I am now ready to turn this augmented matrix back into equations. So remember, X column, Y column, Z column, constant. So if you want, you can draw that dashed line there to remember there's an equal sign there. And we always start at the bottom since that is our one variable or only Z equation. So to turn row 3 back into an equation, we've got 0x, 0y, and Z equals 3. Ta-da! First part of my solution. We move up to our next row. This says 0x plus 1y, or just y, minus 2z equals negative 7. So now we are going to back substitute this one variable equation into this two variable equation. So take that 3, plug it in for the z, and y minus 2 times 3 equals negative 7. So negative 6, add the 6, and we get y equals negative 1. Our last row of row echelon form is 1x minus 2y plus 1z, or just z, equals 7. And now we back substitute our 3 in for the z, our negative 1 and for the y. So x minus 2 times negative 1 plus 3 equals 7. This gives me positive 2 plus 3 is 5, minus the 5 to move it to the other side, and x equals 2, giving us our final coordinate answer of 2, negative 1, 3. And again, folks, it's pretty sweet that we got integers for our answers, but I will tell you that sometimes students do all this crazy row echelon form stuff right, and then goof when they are manipulating or solving for the variables over here. So once you have that solution, I do still recommend that you plug it into all 3 equations to check. So folks, that is a few example problems on how to do row echelon form. On the next page, we will be getting into what infinitely many solutions looks like when we do row echelon form. And then in the last lesson, we'll talk about reduced row echelon form. And folks, for this section, you will need a graphing calculator. So if you haven't gotten one yet, please make sure that you get one as soon as possible so that you are able to follow along with those steps.